Welcome to The Explainer. Today, we're doing something a little different. We're not just learning about a theory, we are investigating a full-blown cosmic mystery. We're going on a hunt for a glitch in the very code of reality. Okay, so let's just dive right in, because the question we're asking today is a big one. Is the universe playing fair? Or has it been cheating this whole time? Hiding a whole deeper layer of order right under our noses?
All right, so to start any good investigation, you first need to understand the scene of the crime. And in our case, that's the bizarre, almost unbelievable world of quantum measurement. So here it is, the central puzzle that has absolutely baffled physicists for a century. Before you look at it, a particle is everywhere and nowhere at once. It's just this cloud of pure potential. But the moment you observe it, bam, it snaps to a single, definite location. The very act of looking seems to force reality to make a choice. So what's the official story? For nearly 100 years, the accepted truth has been that the universe just, it rolls the dice. The outcome is fundamentally probabilistic. What does that mean? It means there's absolutely no underlying reason it lands here instead of there. It's just pure, unpredictable, random chance. But what if all that randomness is just an illusion? A really, really good cover-up for something much deeper. A new theory is challenging this fundamental assumption, and it suggests that what we've been calling randomness isn't the whole story at all. It might just be a clever disguise. And that brings us to our main suspect, a theory called fractal resonance cognition, or FRC for short. And what it proposes is pretty wild. It says there's a secret set of rules governing everything, and it's all based on these repeating patterns at every single scale, fractals, and the way things vibrate together in harmony, what we call resonance. This image here gives you a great feel for the core idea. On the left, you've got what looks like total chaos, right? A random spray of possibilities. But FRC suggests that this chaos is actually being guided by these hitting resonant patterns into that coherent, orderly wave you see on the right. So it's not a random collapse, it's a guided deterministic resolution. So here's the crucial point. It's a huge shift in perspective. Standard quantum mechanics says the universe is basically a game of chance. It's playing dice. But FRC argues that no, it's a game of profound skill, and we've just been watching it with blurry vision. We're just not seeing the whole board. Okay, so how on earth does FRC explain the randomness we see everywhere? Well, it's through this really cool concept called undersampled determinism. I want you to imagine looking at an incredibly detailed, complex fractal image, but you can only see like a handful of pixels. To you, it would look completely random, right? Like digital static, or what physicists call Poisson noise. FRC suggests that our scientific instruments are basically those low-resolution viewers, fundamentally unable to see the full, deeply ordered pattern of reality. We see the noise, but we're missing the music. But, a radical theory is one thing. Every good detective story needs hard evidence. It needs a fingerprint, a smoking gun, something that proves the official story is wrong. And that really is the billion-dollar question, isn't it? If this whole deterministic process is so good at mimicking randomness, if it's so effective at hiding its tracks, how could we possibly catch the universe in the act? Simple. We set a trap. See, FRC makes a bold, very specific, and, this is the most important part, a falsifiable prediction. It predicts a telltale sign, a clue that appears just before the crime happens, something that has no business being there if the process were truly random. And here it is. This graph. This is the potential casebreaker. It's what the theory predicts we'll find. A weak pre-collapse drift. In the moments leading up to a measurement, the system will show this tiny, measurable bias toward one of its possible outcomes. It's like the dice are weighted, but you can only feel that imbalance for a split second right before the throw. Standard physics says this is impossible. It simply cannot happen. So this prediction gives scientists a very clear mission. Design an experiment, set a trap with incredibly sensitive instruments, and see if they can spot this forbidden drift. It's time to go hunting for the glitch. And this is the key. This isn't just philosophy. FRC puts its life on the line here. The theory makes a concrete prediction that we can actually go out and test in a lab. If that pre-collapse drift isn't found, well, the theory's in serious trouble. But if it is there, oh man, it changes everything. Now, what makes this so tricky to spot is that the universe does a fantastic job of hiding its tracks. This chart shows how most of the time, FRC's predictions line up perfectly with the standard probabilities of quantum mechanics, what's known as the Born rule.
So in most situations, its behavior is totally indistinguishable from the official story. It's hiding in plain sight.
But this is where we might find the evidence. The theory predicts that the disguise can slip when it's under pressure. If you do very, very fast measurements, what this chart calls a short locking horizon, the system might not have enough time to perfectly fake that randomness. And that's when these tiny deviations, these little biases, might appear. That is the glitch we're hunting for. That's the moment we might just catch the universe showing its hand.
Okay, but the mystery doesn't just end with quantum particles. The theory's name itself, fractal, resonance, cognition, points to something much, much deeper and way more personal.
This quote from one of the foundational papers says it all. The theory isn't just about physics. Remember, it's called fractal resonance cognition for a reason. The authors believe that the very same fundamental rules, these self-organizing, resonant patterns that might guide a particle, could also govern how complex systems, like our own brains or even AI, learn and process information. I mean, that's a radical proposal, right? That the physics of the very small and the processes of thought might be two sides of the same coin.
And that leaves us with one last really provocative thought. If this glitch really does exist, if the universe is truly built on this hidden layer of deterministic resonant order, then could our own thoughts, our very consciousness, be just another expression of that same fundamental pattern? Not some ghost in the machine, but the resonance of the machine itself. The hunt is on.